Bismillahirrahmanirrahim. I warmly welcome you all to the first international conference on advances in civil and earthquake engineering 2021. My name is Inzimam Khalid and my co-authors in this research are Osama Khan Jadoon, Shabir Ahmed from Department of Mechanical Engineering UET Peshawar and Shahid Ali Wajahatullah and Waliullah from Civil Engineering Department UET Peshawar. The topic of our research is design and simulation of dynamic probing super heavy machine. The contents of my presentations are introduction, objectives, methodology, design and analysis, conclusion and references. First of all, I would like to tell you what the dynamic probing is. Dynamic probing is basically involves a driving of steel cone vertically into the ground using sliding hammer and recording the number of blows for each 100 mm of penetration. We can shortly write it as DPSH, Dynamic Probing Super Heavy Machine. The dynamic probing super heavy machine basically used for dynamic probing and standard penetration test. It is used to determine in situ strength of the soil, parts of dynamic probing, and it can be automatic or manual. So the main purpose of our research is that the students from civil engineering department perform standard penetration tests manually by lifting a weight of 63.5 kg up to the fixed height of 0.76 meter and drop it freely manually by using hand. So they came up with to us that we have to design a machine that lifts 63.5 kg up to the height of 0.76 meter automatically and drop it freely and count the number of blows and penetration as well. So that was our main purpose, our main problem of the main purpose of the research. So to design and simulate a machine that performs SPT without any human effort. That was the main aim of our research. So there are a lot of other objectives as well. That design is simulated by own. The machine should be compact and economically better product. So first main objective of our research was to design a complete machine and its parts according to standards and to simulate complete machine according to standard and design parts. The methodology we have used, that first of all we have done a literature overview. That literature we need for this research, we have overviewed it, and then we have moved to the design portion. We have designed the complete machine and we have done the simulation as well. So methodology, I am going to tell you the main portion and the main problem we have faced and what are the main purpose of this research and this paper. The main research we are going to show in this paper and that we have used in the machine. So methodology, we have designed complete parts of the machine. In this slide you are seeing the vertical skeleton of the machine, the two views of the skeleton of the machine. The first one is the side view of the skeleton of the machine and the second one is the top view of the skeleton of the machine. The methodology, the main purpose was the main problem we are facing in design of the machine, that how the machine will lift the 63.5 kg up to the height of 0.76 meter and drops it automatically. So we are facing the two main problems during the design. First one is that we have to fix the machine height of 0.76 meter, that the machine height should remain constant on each blow. The machine height should not exceed 0.76 meter. And the second one is the weight. When weight reaches the required height of 0.76 meter, it will automatically be dropped. So we have used the bell crank mechanism along with the stopper chain. Bell crank mechanism was the main part of our research. The bell crank mechanism consists of two levers and a central quarter circle. It's basically convert the direction of motion through different angles, through 180 degree, through 90 degree, and through 60 degree as well. The bell crank mechanism that we have used is change the motion direction of motion through 90 degrees. The bell crank mechanism is basically posted is attached with the mast. The two levers of the bell crank mechanism are arranged in such a way that first one is pointed toward the stopper that is connected with the chain, and the second one is pointed towards the upper part of the assembly. When we drive when we give power to the chain, the power calculation according to our research was 0.2 horsepower. Power supply is enough to lift 63.5 kg up to the height of 0.76 meter. So when the stopper engage with one lever of the bell crank mechanism, it lifts the weight up to from sliding assembly to the required height. When the upper lever touches the upper part of sliding assembly, it becomes pressed, and the lever pointing towards the stopper of the machine automatically moves through 90 degree inside, and it's automatically become disengaged. Now the second main problem was to maintain the fixed height of 0.76 meter. So the sliding assembly of the machine has basically two main functions. The first one is to maintain the fixed height of 0.760 millimeter or 0.76 meter, and the second one is the weight will be supported by sliding assembly, and the sliding assembly consists of sliding rods and connected plates. As you can see in the drawing, that different views of the sliding assembly are shown. The sliding assembly have basically the two rods and the upper and the lower plate, and the weight slides on the two rods of the sliding assembly. The sliding assembly have the fixed height of 0.76 meter, and it is connected to the machine. And sliding assembly slides automatically with the blows, and the height becomes fixed on each blow of 0.76 meter. Now I am going to show the final assembly of the machine. When we assemble every assembly part is fitted perfectly. The 3D view of assembly is as follows. As you can see, the sliding assembly is connected to the vertical skeleton of the machine, and there are the two different views of the final assembly of the machine. The sliding assembly is basically consists of sliding weight and two rods that fix the height of 0.76 meter, and also inside we have the chain connected with the stopper. That stopper engaged with one of the lever of the bell crank mechanism, and when the bell crank mechanism touches the upper part of the sliding assembly, it's disengaged automatically and drops freely, and penetrate the rod into the soil. We also have simulated through a prototype. We have designed a prototype of the machine and also simulated through SolidWorks. The prototype we have designed consists of different parts like driving rods, chains, sprockets as the main parts of the assembly. Railings, instead of sliding mechanism, we have used the railings in the prototype, and bell crank mechanism, bearings, sliding rods, hammer and stopper mechanism, and sliding assembly to show the practical how our research will work practically as well. So what are the main outcomes of our research? From our research that we have designed a machine that become helpful in identifying soft areas and voids or cavities within the soil, and which help us to identify buried objects in old foundation. It also help us to find the soil strength parameters, dissolution parameters of the soil as well. So the conclusion of our research is that this paper has discussed the design and simulation of dynamic probing super heavy machine. The main objective of this project is used to perform standard penetration tests in special conditions using an automatically operated machine. The main objective of machine is to give us two readings. First one is the number of blows and second one is how much penetration occurred after each blow. The dynamic probing heavy machine has its own standards that height is 0.76 meter and weight should be 0.63.5 kg. The main function of the machine is to lift 63.5 kg up to the 0.76 meter and drop it freely, and height should remain constant after each blow as discussed before. The two main problems that came in way were the design and assembly that it helps to maintain a fixed height, and second one was that how weight will automatically drop when it raises up to the required height. The solution proposed for the first problem is the sliding assembly design, and the second one is we have designed a bell crank mechanism which help us in automatic drop off with the weight from the fixed height of 0.76 meter. The group has attained a solution of both the problem that causes hurdles in the way of design and fabrication. These are the references from which we have studied and which we become able to, the knowledge we have got from these references become implemented in this research. Thank you. You have listened carefully. Thank you for the listening. If you have any queries, any questions, you can ask freely.